Good morning, pre-calculus students. We're going to talk about the unit circle here, and just a little background before we get into it. The unit circle is a diagram, which is a platform used to explain trigonometry ratios. You can use it to help explain specific measures of angles that are expressed in both degrees and radians, and it's helpful when evaluating trig functions such as sine of 120 or cosecant of 3 pi over 2 or over 4. Over the next few days, we're going to learn how to generate the unit circle and how to use it to evaluate these types of expressions. The mastery of this unit circle will be very, very beneficial for you in calculus. Your teacher should have provided you with a PDF option. If you can print it out, that would be great. Otherwise, what I'll have you do is this is going to be our start of the unit circle. Please pause the video and recreate what you have here, and I would do it on a full sheet of paper. You want to make this as big as possible because we're going to put degrees, radians, and then ordered pairs as we go about. So pause it, make this as big as possible. Don't worry about the 30, 60, 90, 45, 45, 90 triangles here. All right, so hopefully you had a chance to draw this in. Before we get started, what I'd like to do is just kind of identify a couple of key angles that are really important ones that are on the quadrants. These are the quadrantal angles. So the angles that are kind of the spot where we can't draw one of these special reference triangles. So we're going to start at 0 degrees. That's when the initial side and terminal side are the same, and you basically start right where you go. Well, if I go all the way around the circle, we learned that that was 180 degrees. Right, which I'm going to actually say right now that's the same as pi, right? 180 and pi, these are equivalent. So if I go another 180 degrees, that would be a coterminal angle of 360, which is coterminal with 0. Or I went 1 pi plus another pi, so that would put me at 2 pi. So notice I could say 0 radians or 2 pi, and they represent the same coterminal angle because we end up in the same spot. Well, what about going half of the value of 180, right? If I go half of 180, that's 90 degrees. And if I cut pi into 2 equal pieces, that's considered pi over 2. So now I do like to put the other quadrantal angle in. So now I'm thinking every quarter turn of a circle is 90 degrees. So 90 plus 90 gives me 180. 180 plus 90 gives me 270. And then 270 plus 90 puts me right back at 360. But what about pi over 2? Well, pi over 2, if I do pi over 2 plus pi over 2, that's 2 pi over 2, but those reduce out and you're left with pi. So what if I go another pi over 2? That would put me at 3 pi over 2. If I go another pi over 2, that will put me at 4 pi's over 2, but 4 over 2 is 2 pi. And we always write the reduced fraction here, so we don't need those items. So those are the special angles. Those are the quadrantal angles, and we'll talk about how sines, cosines, and all the other trig functions are evaluated when you're at those 4 special points. But that's going to be for another day. What I'd like to do now is look at the 30, 60, 90 triangles and how they fit within this circle. So I'm going to focus on a reference angle of 30 degrees. Now keep in mind it should have a 90 and a 60 here, but we're really focused on the reference triangle and the reference angle. So if I'm in quadrant 1, the reference triangle would fit in perfectly with the line that's provided right here. And the angle that is formed is 30 degrees. I'm going to use blue for this one. So there's 30-degree reference angle. Now, what I would like you to do is we're going to deal with just the 30-degree reference angles. And what we're going to do is we're going to reflect this over. So what if I go ahead and reflect this triangle so it comes right over here and fits nicely in the spot? Let me show you how I do that. Okay, so I flipped the triangle, and then I'm just going to slide it right into this spot right here. So now I have and I had to flip it, but this should say 30. So I have a reference triangle and a reference angle of 30. Now, when we name the angle, we do have to go from the initial side to the terminal side. So this angle is definitely bigger than 90, but it's less than 180. And how many degrees less than 180 is it? It's 30 degrees less than 180. So 180 minus 30 gives me 150 degrees. All right. So now I'm going to take this reference angle and I'm going to flip it or reflect it over the y-axis. So I'm going to go 30 degrees past 180. And you probably know what that is already. If I do 180 plus 30, that would get me at 210 degrees. So I'll show you what that reflection looks like. I should be able to just reflect this down. And then grab the triangle. So you can see I have a 30-degree reference angle, and I'm going 180 plus 30, and that's how I got the 210. So now I'm going to reflect this point over to the other side. So I'm going to reflect it over here. And you might be thinking, okay, if my angle starts at 0 and goes all the way around because these are positive angles, so I'm going counterclockwise, then I will be at a 30-degree reference angle right here. But that means I'm going 360 minus 30, or 330 degrees right there. Okay, so let me show you how this would look if I flip this triangle. You can kind of picture the original triangle that we had up here reflected downward, and you can see that that reference angle is 30 degrees. So 360 minus 30 gives me the blue angle of 330 degrees. All right, so what I would like you to do is take the 45 and let's go ahead and mark all of the 45-degree angles using this triangle. Picture it flipping over to the other side and flipping down and flipping back over. So I'll have you guys go ahead and do that as I do mine here. And then, all right, so you can see I took my 45-degree reference angle and that fit in perfectly here. So I have 45 degrees. If I flip this one over to this side, I get 45-degree triangle matched up right here. Well, that's 45 degrees less than 180. So I did 180 minus 45, and I have 135 degrees, which gives me this angle right here. And then if I reflect it downward, I get the 45-degree triangle right here. So I'm going 45 degrees past 180. Well, 180 plus 45 is 225. And if I reflect this point over here, or some people like to think of it as taking the 45-degree angle here and reflecting it down over the x-axis. So if I'm in quadrant 4, that means I went all the way around the circle until this line segment right here, which ends up getting me to be 315 degrees, which notice 360 minus 45 is 315. So that's how you do the 45-degree chunks. Now I'd like you to go ahead and do the 60-degree chunks. So we're going to do that same work. Take this triangle, which is a 30, 60, 90. It's just tipped upward, so it's kind of the taller, skinnier triangle. And then you're going to reflect it over into quadrant 2, reflect into quadrant 3, and reflect into quadrant 4, and think about how that relates to the reference angle 60 degrees. So go ahead and do that. Hit pause, and then I'll show you my answers in just a second. Okay, so I had my 60-degree angle. If I reflect it over here, you'll notice that I would have the triangle written just like this. And some students think of it as here's 60-degree chunk. If I go another 60 degrees, I get 120. Other students think of it as if I have my reference angle at 60 degrees right here. Well, if I start at the initial line and I go to the terminal side, I would be 60 degrees short of 180, or 180 minus 60 is how I got the 120. All right, and then if I go and draw the reflection down over the x-axis, that would put me as a 60-degree reference triangle right here. So I would be going 60 degrees past 180. So another way to think of that is 180 plus 60. And then if I go and reflect it over into the fourth quadrant, or reflect this triangle down, I would get a 60-degree reference angle here. But when I measure it, I start at the initial side and go all the way around because it's a positive number. So another quick way to find this is 360 minus 60. All right, so we dealt with the degrees, and students are usually pretty happy and enjoy the degrees because it makes a lot of sense. But what we're going to do now is look at the radian measures. And what we have to think about, there's a couple ways to think of this. We already talked about how pi is equal to 180. And if I cut pi in half, I get pi over 2, and that's 90. But what if I cut 90 in half? Half of 90 is 45. So here's the way my brain works, is if I have pi over 2, and what if I cut that in half? So I times it by 1/2, multiplying fraction gives me pi over 4. All right, now you could go ahead and say, well, 45 degrees is the same as pi over 4, and re-reflect all of those spots. So all the green 45-degree reference angles, we could figure out what they are in terms of pi over 4. But here's the way I like to think of it, and this may help. Every 45 degrees is one of the pi over 4s. So if I go another 45 degrees, that would put me here. But that wouldn't be pi over 4. That would be 2 pi over 4. But we don't write a non-reduced fraction. So we would divide this out, and that would turn into pi over 2. That's why this one is called pi over 2. It's the reduced fraction. But what if I go another pi over 4? So I go 1, 2, 3 pi over 4. Well, 3 pi over 4 is as far, that's already reduced, so that's the radian measure, and 3 pi over 4 is equal to 135. So what if I go another pi over 4? Another 45 degrees would put me at 180. Well, that's 4 pi over 4, but the 4 is reduced out, and that's why we call it pi. But I like to think of this 4 pi over 4 because what if I go another 45 degrees? Well, then that puts me at 5 pi over 4, and that's already reduced as far as it can go. And then if I go 6 pi over 4, notice 6 pi over 4 is the same as 3 pi over 2. So I'm going to leave this one. I don't need that 6 pi over 4. But if I go another pi over 4, then that puts me at 7 pi over 4. And then if I go one more 45 degrees, that's 8 pi over 4, which we're going to write as 2 pi. All right, so what I would like you to do is I want you to take this kind of fractional thinking with our pi's, and let's do it with 30 degrees. So here's what I'll show you with 30 degrees is, think of this, pi is 180, right? 180 divided into 6 equal pieces is 30 degrees. All right, so 30 is equal to pi over 6. Now this one's a little bit more unique with how we think of the fractions because we can actually find the 60-degree chunks as well. And the reason why is if this is pi over 6, this is 1 pi over 6, what if I go another 30 degrees? That puts me right here at 60 degrees. So this would be considered 2 pi over 6, but 2 over 6 reduces down to pi over 3. So we're just reducing fractions here, pi over 3. And then if I go another pi over 6, so there's 1 pi over 6, 2 pi over 6, this is 3 pi over 6, but 3 over 6 is 1/2. So the next one would be considered 4 pi over 6, but that can be reduced, so that's actually 2 pi over 3. And then if I go another pi over 6, this would put me at 5 pi over 6. And if you haven't done so already, you should pause the video and just continue on and find all the rest of the angles. All right, so I'm going to finish up here. So this would be 6 pi over 6, but we're just going to leave it because 6 is reduced out. And then I would go another pi over 6, so 7 pi over 6. And then I would go 8 pi over 6, but I know that 8 over 6 reduces down to 4/3, so 4 pi over 3. So this was 7 pi over 6, 8 pi over 6, 9 pi over 6, but 9 over 6 reduces down to 2/3. And then we would go 10 pi over 6, but 10 over 6 reduces down to 5/3. So this reference angle right here would be its angle would be 320 or 5 pi over 3. And then the last one would be 11 pi's over 6. All right, so the 30-degree angle kind of helped us find all the other ones. And now we know all of the special angles, 30, 45, 60, 90, and all the other ones are generated from these angles. So we're going to do a lot of work in the first quadrant. And if you can master this first quadrant, then you're going to be able to just generate using the idea of reflection to find all the other ones. So that's what we got. Hang on to this. You're going to want to make sure that you have this for the notes, because the notes on Thursday, Friday, we're going to fill in all of the actual X, Y locations when we have a radius of 1. Have a great day. Thank you.